This video documentation has been produced by Ingersoll for Caterpillar Incorporated. It is intended to supplement Ingersoll's D7H case-to-frame assembly, machining demonstration, and inspection report. The machining and inspection of Caterpillar's D7H case-to-frame assembly were performed by Ingersoll to demonstrate the flexibility, productivity, and accuracy capabilities of Ingersoll's vertical Masterhead type machining center. The demonstration was performed on an Ingersoll vertical Masterhead type machining center located at WCI Machine Tools and Systems Company in Belvidere, Illinois. This machine was designed with a single patented masterhead and tooled to produce cast iron machine tool parts. The machines we will propose to Caterpillar will be similar to the machine used for the demonstration. However, special features will be included to optimize production of the case-to-frame assemblies. These features include dual patented masterheads, dual robotic tool changing systems with double grippers, and dual spindle unit serving systems. The Ingersoll Machining Center features a patented masterhead which serves as a driver for interchangeable spindle units. The masterhead design is greatly simplified by elimination of all gearing except that required for the rotary axis feed for positioning the spindle units. The spindle units are stored alongside the machine at the rear of the machine columns. A shuttle car is used to position the spindle units for loading onto the masterhead or for returning the spindle units to the storage area when they are no longer needed. The robotic tool changing system, under direction of the CNC, performs tool changes in all spindle units. The system shown here uses a single tool gripper assembly for removing and replacing tools in the spindle units. The machines we will be proposing to Caterpillar will include tool changing systems equipped with double gripper assemblies to minimize tool change time. In our proposed method, the double gripper assembly uses one set of grippers to remove the tool that has just been used, then indexes 180 degrees and inserts the next tool to be used. The spindle drive is powered by an infinitely variable 10 to 2,500 RPM DC motor. The spindle units operate at drive motor speed or carry integral gearing for speed reduction or speed up according to their purpose. This provides a speed range that otherwise would require two different spindles, one with heavily preloaded roller bearings for low RPM cuts and one with lightly preloaded ball bearings for light cuts at high speeds. The demonstration begins by using a heavy-duty vertical spindle unit with 4-to-1 gear reduction to rough and finish mill pads and mounting surfaces on top of the case-to-frame assembly. In this operation, approximately 104 horsepower is used to rough mill the rollover protection structure pads using an 8-inch diameter max-eye shear face mill at 240 RPM and with a feed rate of 65 inches per minute. This spindle unit is designed to transmit 125 horsepower and is capable of speeds up to 625 RPM. After completing the rough and finish milling operations on top of the case frame assembly, the heavy-duty vertical spindle unit is replaced by a precision vertical spindle unit with 2-to-1 gear reduction. This unit is used for drilling and tapping the pads and mounting surfaces on top of the assembly. When all machining on top of the case-to-frame assembly has been completed, the masterhead deposits the precision vertical spindle unit into the empty cradle on the shuttle cart. The cart then positions itself for loading the next spindle unit onto the masterhead. This is a heavy-duty horizontal spindle unit with 4-to-1 gear reduction, which will be used for all milling and heavy-duty drilling and boring on the sides and transmission end of the case-to-frame assembly. After the spindle unit has been loaded onto the masterhead, the shuttle cart returns to the spindle unit storage area, where it will unload the used spindle unit and load another one in preparation for the next spindle unit exchange. Prior to beginning the rough milling operations, the robotic tool changer places an 8-inch diameter max-eye shear face mill into the horizontal spindle unit. In order to provide maximum rigidity while rough milling in the vertical plane, the masterhead ram is locked in place and the machine cross rail is used. In our proposed method of machining Caterpillar's case-to-frame assemblies, dual master heads will be used for simultaneous mirror image machining on the sides of the assembly. Drilling of the radiator pads was performed using a 2 3/8 inch indexable carbide drill at 625 RPM and with a feed rate of 5 inches per minute. Some of the machining operations performed during the demonstration, which required multiple tool changes to complete, would be consolidated into lesser operations with the use of special tools designed for a specific purpose. For example, a combination boring bar would be used to simultaneously rough the pivot bore and finish bore the clearance diameter. Both sides of each radiator pad would be rough and finish milled at the same time using gang-type cutters. The final series of machining operations were performed using a precision horizontal spindle unit with 2-to-1 gear reduction. These operations included drilling, tapping, grooving, and finish boring of the sides and transmission end of the case-to-frame assembly. After completing all machining operations, the case-to-frame assembly was inspected in our quality control room on our largest Zeiss Mauser coordinate measuring machine. The inspection consisted of checking all areas machined during the demonstration, including bore diameters, bore hole and face locations, and milled surface flatness. The inspection showed the case-to-frame assembly to be well within acceptable tolerance limits. Upon completion of the inspection, all data was computer logged, analyzed, and reported. Copies of the actual inspection results are included in Ingersoll's written demonstration report. The successful completion of this machining demonstration illustrates the flexibility, productivity, and accuracy capabilities of Ingersoll's vertical masterhead type machining center and its ability to efficiently produce Caterpillar's case-to-frame assemblies. And what's equally important is that it demonstrates the highly technical range of skills and combined effort Caterpillar and Ingersoll have shared in order to serve Caterpillar's Plant with a Future objectives.